Okay, so this is how to solve absolute value inequalities. We kind of talked about how to solve absolute value equations or linear equations in chapter 1. If you remember, we would have canceled out what this is and changed that to an equal sign. And all we did there, if you look back at your chapter 1 notes or even the chapter 1 test that we just took, we knew that we had to copy our first equation, write a second equation with the opposite value after the equal sign to solve two different equations to get us two answers for absolute value. So now we just do the exact same thing, except we're using compound inequalities. That's pretty much essentially what this is. It's a compound inequality. I know it doesn't look like it. We talked about compound inequalities last week, but this itself is a compound inequality, and I'll show you why. The first thing we need to address is when we look at our sign, or even our sign over here, that alone tells us whether this is going to be an and or an or compound inequality. Now, let's look here. We know, and what I need to tell you is when we have an absolute value, we'll pretend like we have an absolute value of x. And our sign is eating the absolute value, or the absolute value is greater. This is an or compound inequality every single time. Now the opposite. If we have an absolute value and the sign is eating away, or our absolute value is less than, automatically we know this is an and compound inequality. Those are the two differences. So here, our sign is eating the number, or it's telling us our absolute value is less than. That tells us this is an and compound inequality. And we know there's two options for an and compound inequality. We can either A, copy our first equation and put an and in the middle. And then what we have to do, put x plus 7 again. We copy what's inside the absolute value bars. We change our sign, and we change our 2 to a negative. We can solve both of these separate, but at the end, we need to put them together into a compound inequality because we've already talked about that, right? The easier way, or I wouldn't say the easier way, but the quicker way, and I know that high school students really like to solve things quick, right, is we can actually solve these both at the exact same time by putting them into an and compound inequality. So, again, we discussed, this means it's and. All we have to do is we copy what's inside our absolute value bars. We have x plus 7. Copy our sign. Put our 2 there. We've literally just copy and pasted this equation and moved it here, right? Now, instead of writing two different equations, flipping our sign and changing this to the opposite, we can actually copy this sign and put it right here and change our 2 to the opposite. What's the opposite of a positive 2? It's a negative 2. Now we can solve both at the same time. We've kind of already talked about this, right? All we have to do is get x by itself in the middle. Now the only way to get x by itself is removing this positive 7, and in order to cancel out a positive 7, we have to subtract 7, make it 0, right? So we subtract 7 from both sides. And now our x by itself in the middle, because this cancels out. Let's go ahead and keep our signs the same. Again, we only switch our signs around when we are multiplying or dividing by a negative number. So let's start over here. Negative 2 minus 7 is a negative 9. Over here, 2 minus 7 is a negative 5. This is our answer, right? Now, if you want to split it up into 2, you'll get this exact same answer. It just kind of depends on what you want to do. If you want to split it up into 2 equations, I'm totally fine with that, remember. I just want to show you guys the one that takes the least amount of steps. So, now we're here. We can graph it. We talked about graphing before. You need at least 5 numbers in my class, as long as they go in the correct order. So, these two inequalities tell us whether we have an open or a closed circle. We know that that line underneath tells us that our number's also included, which means we have to have a closed circle on both the negative 9 and the negative 5. So let's make it happen. We have a closed circle on the negative 9. We have a closed circle on the negative 5. Okay? Let's graph this inequality first. X is less than or equal to a negative 5. So we have two options here. Again, you can either know that the variable is on the left side, which tells us we can just copy our arrow and have it pointing left. Or we also know that when our sign is eating the number, that tells us our variable is less, and less is always left, right? So our negative 5 will be pointing left. Now, this matches what an and inequality graph is going to be. We just have to make sure that our negative 9 is also going to the right so they meet in the middle. If it's not, then we have an issue, right? So we look at our second inequality. We have negative 9 is less than or equal to x. So you have two options again, right? We know our variable is on the right side, so we would go the opposite direction of our arrow, which our arrow is pointing left. We need to go right, which that tells us this is going to work, right? The other option you can do is we know that variable is greater, and if the variable is always greater, then it always goes right. So our solution lies in between and including negative 9 and negative 5. All right, let's move on to the next one. So we're going to do the same exact thing here, except this is going to be a few more steps. But we see our sign here. It's eating the number, not the absolute value, right? That tells us our absolute value is less. And if our absolute value is less, we look here. Hopefully you put this down on your notes. It's an and, compound inequality, which means we can solve it both at the same time. So let's do it. We have 8x minus 11. We copy and paste our first equation is less than 0. Now all we have to do is copy the sign, put it over here, and we have a problem, right? Can 0 be negative? No. And 0 cannot be positive either. So instead of solving this entire equation, we actually have a very, very simple answer. When we look, our absolute value is going to be less than 0. Now we've talked about anything inside of the absolute value bars is always positive. So is there any way at all that anything we put in here is going to be less than 0? No, because anything less than 0 is negative, right? Even if we were to put a negative 7 in here, the absolute value of a negative 7 is a positive 7. And if we were to put it right here, we would have to say that 7, a positive 7, is less than 0. That's not true. So our answer is no solution. And no solution does not require a graph. So these ones are going to be extremely easy. Okay, you guys know what to do. It's monitoring progress. What I would recommend doing is I would recommend pausing the video, doing it yourself, and coming back to see if you've got it right. Okay, this equation is kind of really not an equation at all because it's already solved for us. First thing we see is our sign tells us that it's and, because it's less than, our absolute value is less than the number, right? So let's make it that way. We have x, let's copy our sign, and now let's copy our sign over here, and make it negative 3.5. X is already by itself, right? So since x is already by itself, our equation is solved for us. All we have to do is graph it. And again, always put 5 numbers, but for the shortness of the video, I'm just going to put 3. That's fine. Okay, again, these tell us we both need closed circles. This inequality alone alone tells us that our positive 3.5 is going left. And then this inequality alone tells us our negative 3.5 is going right. It's an and compound inequality with an and graph. Perfect, we can move on. Over here, if you remember, this tells us it's an and compound inequality, but we have to read it. Let's read it from right to left. The absolute value of k minus 3 is less than or negative 1. Is it possible for an absolute value, which is always positive, to be less than or negative 1? No, it's not. And the reason it's not is because anything less than or negative 1 is still negative, right? We got things like negative 2, negative 3, negative 4, and negative infinity. There's no possible way that an absolute value is going to be negative. It's not going to happen. So no solution. Okay, and we go over to 3. Solve it the exact same way. This tells us it's an and compound inequality. Let's solve them both at the same time. 2w minus 1 is less than 11. Again, we copy and paste our first one. Keep the sign the same. Put it on the left side. Change our 11 to a negative 11. Now we have to get the w by itself. In any equation, again, we do not divide the 2 first. We have to add the 1. So we're going to add the 1. Okay, negative 11 plus 1 is a negative 10. Keep our sign the same. Put our 2w in the middle. Keep our sign the same. 11 plus 1 is 12. Now we have one final step, and that one final step is to get that w alone. 2w, remember, if there's no sign in between, we assume that it's 2 times w. In order to get rid of a times or a multiplication, we have to do the opposite, which is dividing. And remember, what we do to the middle, we have to do to both of the other sides. Now we'll write our final answer. Negative 10 divided by 2 is a negative 5. We keep our sign the same because we still did not divide by a negative. I know we have a negative answer here, but we divided by a positive 2, so that means we have to keep our sign the same. Put our w, keep our sign the same. 12 divided by 2 is 6. Okay, your graph, you should have had a open circle on a negative 5, 0. Open circle on a 6, and they are going together. It's an and compound inequality with an and graph. We have nothing to worry about. We're going to move on. Again, if that does not make sense, please email me or ask me in class. We're going to move on. We're almost done. Okay, the only thing that's different here is if you notice, our signs are different. Our signs are different, which can only mean that our compound inequality is different. Again, let's think about it. When we have an absolute value that's greater, so in this case, it is an or. And again, what we just got done covering is when we have an absolute value that is less, it's and. Again, that's the only difference. But we know that if we have or compound inequalities, we cannot put them together and solve them at the same time. So the and ones are a little bit easier. So let's solve this first one. We see that our inequality is eating the absolute value, or our absolute value is bigger. That tells us it's an or compound inequality. That means we're going to solve it a lot like a linear absolute value equation, and we're going to write 2 different problems to solve. So let's copy our first one. Copy and paste. C minus 1 is greater than or equal to 5. Or in the middle. Now let's copy what's inside the absolute value. Again, anything in the absolute value bars does not change. So C minus 1. I'm not going to make this. C minus 1 Now we flip our sign and write the opposite of a positive 5. The opposite of a positive 5 is a negative 5. Okay, now we solve both equations separately. Over here, to get our c by itself, we have to add our 1. We have c is less than or equal to negative 5 plus 1. It's negative 4. Keep our or in there. Do the same exact thing over here. We add our 1. We have c is greater than or equal to 6. Now we graph it. And again, this is an or compound inequality, which means our or graph is always apart. Remember the reference that I made in class last week? If it's peanut butter and jelly, they go together. If it's peanut butter or jelly, they go apart, right? So when we graph, we have 0. Let's put our 4, our 6, put our negative 4, and our negative 6. These two inequalities tell us that they're closed circles. We have a closed circle on negative 4. We have a closed circle on 6, and now we graph them each individually. Here, c is less than or equal to a negative 4. Again, two options. If our variable is less than, it's always left. Or, since our variable is on the left side, we can use our arrow, which is pointing left. Okay, again over here. c is greater than or equal to 6. Again, if our variable is greater, it's always right. Also, the variables on the left side, our arrows pointing to the right, so we make it go right. Again, I do not care what method you use to graph, but it needs to be pointing the right direction every time. So if you want to use the arrow method that we talked about, where the variable has to be on the left side, do it. If you want to use the greater than or less than that we just talked about, do it. It's completely up to you. Okay, now we're going to look at B and C. They both are going to be the exact same answer, but I'm going to solve one to show you guys why it works, and then the other one we'll talk about what you could just do instead of solving. So we look at B. We're going to solve the exact same way. Let's copy our first equation. 10 minus n is greater than or equal to a negative 2. Put our or in the middle. Now let's change our second equation. Keep the absolute value the same, 10 minus n. Flip our sign, change our negative 2 to a positive 2. So, this is an or. Let's solve the first one. We have to subtract our 10, which gives us a negative n. It's less than or equal to negative 8. Okay, we can never have a negative variable. In order to get rid of a negative on a variable, we have to divide by a negative 1. Because we always assume there is a hidden 1 right there. So we divide by our negative 1. We have m. Now, since we divided by a negative, we have to flip our sign. And negative 8 divided by a negative 1 is a positive 8. Okay. Put our or in the middle. Let's solve the other equation. We have to subtract our 10 again, which gives us a negative m is greater than or equal to a negative 12. Again, we have to divide by a negative 1 because we can never have a negative variable. Divide by a negative 1. We have m. We have to flip our sign because we divided by a negative. And negative 12 divided by a negative 1 is a positive 12. Okay, so here's our answer. And we've talked about our graphs before. We know an OR graph needs to be separate. They need to go apart from each other, right? So if we were to graph it, I'm going to put my 0 over here. We'll put our 8 here, our 12 here. Let's graph the 12 first. Close circle on 12. And again, you can use the arrow. Since the variable is on the left side, the arrow is pointing left, so that means it goes left. Or we know our variable is less, and less is always left. Remember, these are two separate inequalities. So if they meet in the middle, they don't stop. They keep going, right? They keep going forever and ever and ever. So we're going to graph our 8 now. It's a closed circle on 8. Now our arrow is pointing right with our variable on the left, which means we can make it go right. Or our variable, which is m, is greater, which means it's always right. Okay, this is why we have a problem, right? We talked about this in 2.5 a little bit. If 8 is included, and it's going all the way to the right, all the way to infinity, and if 12 is included, going all the way to the left, all the way to infinity, that means every single answer is covered, right? So our answer is all real numbers. And again, I don't care if you want to put the infinite sign. You can. I'll know what you're talking about. Or you can write out all real numbers. Either or, I will accept. Again, if you have any questions on why that works, please email me or ask me in class. Okay, now let's look at this one. This is what you can do to identify that it's infinite solutions or all real numbers right away. So we look here. Again, we talked about an absolute value is always going to be positive, right? Every single time it's going to be positive. So anything we put in here is going to be positive, even if we put a negative number. If we put a negative 6 in there, the absolute value of a negative 6 is a positive 6. Because remember, we talked about absolute value is distance, and distance is always positive. So we see our sign. It's greater than or equal to. A positive number, that's what absolute value is. A positive number is greater than or equal to a negative number. So a positive number is always going to be bigger than a negative 3. And I know we have this equal to down here, and we know it will never be equal to a negative 3, but that greater than sign speaks mountains, right? So anything in here, a positive number is greater than a negative 3. That's always going to happen. And since it's always going to happen, that means right away, we can just put infinite or all real numbers. So that's the difference between an and compound inequality and an or compound inequality. In an and compound inequality, it never works because we always have a positive number and it's never going to be less than a 0 or less, right? In an or compound inequality, it's going to be infinite or all real numbers because our positive number here, which always comes out of the absolute value, is always going to be greater. So those are the two differences. And make sure you guys remember those because those will be on the test. Okay, one more time, monitoring progress. They're both fairly easy. They both look the exact same except we have a different number here and here. We're going to solve them the exact same way. Make sure you pause this video. All I'm going to do here is I'm going to write the answer so you can check yourself. And if you still don't understand it, make sure you ask or email me. So pause the video. Okay, the answers 4, 4, and 5. For 4, it's going to be x is greater than 5, or x is less than a negative 11. Okay, for number 5, we have x is greater than 4, or x is less than a negative 12. Okay, so the key things that we learned today, we learned the difference between an and an or compound inequality. We already know what the graphs do. And if the graphs don't match, then it's either no solution or all real numbers, right? We also learned that our sign matters when it comes to absolute value inequalities. If our absolute value is greater, it's always or, right? If our absolute value is less, it's always and. Again, make sure you ask questions if you don't understand, and feel free to email me.